Hello and welcome to our first customer-only webinar. I'm Eyal Gutkind, Head of Solutions Architect at ScyllaDB. And in today's presentation, we will cover what was new in 2018, Scylla Manager, and provide some tips on how to make our support process more efficient. 2018 was a great year for Scylla. We have made progress in creating a stable and performant enterprise Scylla version. We improved our monitoring stack, and we started pushing new features into the Scylla Manager. We expect nothing less with the upcoming 2019. We are expected to release Scylla 3.0 and its enterprise companion, Scylla Enterprise 2019.1, early next year, closing the gap on features and operational efficiencies. We hope you will enjoy this webinar. If you will find the webinar platform useful, we will continue to have these customer-dedicated webinars throughout 2019. If you have any questions for us, put them into the Q&A button at the bottom of the window. As a reminder, we will send the slides and recording to you via email after the presentation. And with that, I'll turn the presentation over to Tomer.
Thank you, Eyal. So let's get the show running. Hello, everyone. I'm Tomer Sandler. I'm a solutions architect at ScyllaDB and a customer success manager. Before we dive into Scylla Manager, we wanted to talk about these 6 topics which we think are important and for you to be aware of. First of all, backups. You should have regular backups for your Scylla cluster, not only for disaster recovery scenarios, but think also of human errors. A table or a key space got dropped or truncated. That can happen. You should also test and get acquainted with the restore procedure, so not to encounter it for the first time only when something goes wrong. As for security, we have a link to our security docs here, which now has a security checklist for you to read through and make sure you are aware of all the security features Scylla has and utilize them. Are you using our monitoring? Well, you should. It's easy to use and it's free. Either use our monitoring stack with the Docker image based on Prometheus and Grafana, or use your own Prometheus server and import our dashboards. Basically, any monitoring system that can consume Prometheus metrics will do. As for support, we have a link here on how to interact with our support, and later on, we will talk about our ticketing system, Zendesk. Information collection. In case you do have an issue to report, this link contains the how and what needs to be done in order to provide the full picture to our support. And last but not least, Scylla version. We ask that you use or upgrade your systems to the latest Scylla Enterprise version, currently 2018.1.7. It contains some critical patches, and we strongly recommend that you move to that version. So let's start talking about Scylla Manager. What is Scylla Manager? It's a cluster operations automation tool. Code, basically. It's a centrally managed system. There is no need to SSH into individual Scylla nodes. The Scylla Manager was created specifically for Scylla. It's shard aware, and it consists of 2 components: the server, which is a daemon that exposes REST API, and the SC tool, a command line interface for interacting with the server over REST API. Today, with version 1.3, Scylla Manager is targeting repairs and health check capabilities. Scylla Manager is persistent and highly available because it's using Scylla as its backend. By default, it installs a local Scylla Enterprise as its backend, but you can also use any Scylla cluster as a remote backend. As for CLI and REST API, it supports ASCII tables and JSON files. And there is no need for agent or sidecars. The concept of having a companion application installed together with another application is known as a sidecar. Scylla Manager is designed so that there is no need for sidecar processes running on Scylla nodes. It supports SSH tunneling for its interactions with Scylla clusters. While SSH communication with the cluster is not mandatory, it is recommended as it does not require any database configuration changes and only requires a dedicated user with minimal permissions. Included in the Scylla Manager package is a script which sets up SSH connectivity to all nodes using one simple command. So let's look at this diagram. It presents a logical view of Scylla Manager with a remote backend data store managing multiple Scylla clusters situated in data centers. We have the Scylla Manager server, which is a Go-based server daemon that exposes JSON REST API. We have the Scylla Manager client, which is the SC tool, a CLI tool for interfacing with Scylla Manager. And we have the Scylla Enterprise, which is the internal database, a highly available backend to persist the Scylla Manager state. The server persists its data on the Scylla cluster. By default, it comes with a pre-installed single node cluster running locally, as I mentioned before, but it can be changed to an external backend data store. For simplicity, only one cluster is shown in this diagram. Each node has two connections with the Scylla Manager. One is an SSH connection, which is used for all Scylla Manager activities, except for the Scylla Health Check, which uses a CQL connection. Optionally, but recommended, you can add Scylla Monitoring Stack to enable reporting of Scylla Manager metrics and alerts. Now let's talk about topology awareness. Scylla Manager discovers cluster topology and is aware of nodes belonging to different data centers. By default, Scylla Manager automatically selects a local data center based on ping latency measurements, and whenever possible, it will try to use the host in that data center to interact with the cluster. Integration with Scylla Monitoring Stack. So Scylla Monitoring Stack consists of three components wrapped in a Docker container. We have the Prometheus, which collects and stores metrics, the Alert Manager, which handles alerts, and we have the Grafana, which is the dashboard server. When used with Scylla Manager, the metrics for all of your managed clusters and alerts can be viewed using Scylla Monitoring. Progress of repairs, node status, and other metrics and alerts, including Scylla Manager status, can be viewed using our Monitoring Stack 2.0 dashboard. Scylla Manager has now much easier deployment. We have the Scylla Manager setup. It's a script to configure the service. The wizard contains questions about enabling the service of Scylla Manager. We also have the Scylla Manager SSH setup, which is the command to establish all the SSH connection to all the nodes. These scripts help you with the user creation, the key generation and distribution, and it requires that you have an SSH access to all of the nodes with a sudo-enabled user. These are the flags that you need to use. And as you can see, you only put, after the discover one IP, it will discover the rest of the nodes. And we have the Scylla Manager SSH test. If you encounter the Scylla Manager SSH test allows you to test the SSH connectivity for any issues. And if you encounter troubles setting up SSH connectivity, you can use this command with the -v to have a verbose output to investigate the reason. So let's talk about how we add a cluster and the health check. So we have the sctool cluster add command, which you use with the following flags. And in return, you get the cluster ID. And that indicates that the Scylla cluster was registered in the Scylla Manager. Once that's done, you can now query for the scheduled repair task that was created when the cluster registered in Scylla Manager. And you can see it with the sctool task list command. Now let's talk about the Scylla health check. The Scylla Manager automatically adds a health check task to all new nodes when the cluster is added to Scylla Manager and to all existing nodes during the upgrade procedure. Meaning if you had a Scylla Manager running 1.2 or 1.1, when you'll upgrade Scylla Manager, it will add this task to the clusters that were already registered. The health check task measures the response time to each node in tandem. If there is a response faster than 250 milliseconds, the node is considered to be up. If there is no response, or the response takes longer than 250 milliseconds, the node will be considered to be down. The results are available using the sctool status command. Now, repair jobs in Scylla Manager have a lot of granularity and a lot of options on how to run it. Starting Scylla Manager 1.2, we started supporting multi-DC repairs. You may specify a data center or data centers you want to repair using globe patterns. Globe patterns are like regular expressions, but more simpler. The DC flag accepts a comma-separated list of patterns. It's compatible with ordinary enumeration and also supports exclusion with exclamation mark prefix. Similar for keyspace and tables. Keyspace pattern is separated from table pattern by a dot. This gives you much flexibility in selecting what shall be repaired or not. The expressions are evaluated on run, so when a keyspace or a table is added, it will be automatically picked up. In addition, tasks can also be stopped and updated to be resumed later on. So as you can see, we have multiple examples here of SC-tool repair syntax and the elements that you can run it on. Now, we also have advanced repair. It's also possible to provide detailed information on what should be repaired. You may select a host, a specific host to be repaired, the type of token ranges, which can be primary, non-primary, or all tokens, and the host to be repaired with. This may be handy in scenarios where node broke, but you should use this with caution. Otherwise, you might be repairing not all the token ranges that should have been repaired. So this is an advanced option, and you need to know what you're doing in this case. In this table, we have a comparison of the node tool repair versus the manager repair. So let's walk through it. First of all, node tool repair is local on the node level, whereas the manager repair is global on the cluster level, and it makes sure not to run repair more than once. Node tool repair is an ad hoc operation, whereas in the manager repair, you have two options. You can have a recurrent automated repair task that's created when you register the cluster, or you can also have an ad hoc repair job. Node tool repair is a fire and forget command, whereas in Scylla Manager, you can stop and resume tasks, and you can follow their progress in the CLI, in the SC tool, and in the dashboard in the Scylla monitoring. Node tool repair doesn't have any records. Scylla Manager keeps task history. You can see all the tasks that were successful or failed, so it's good information for that. The node tool repair is shard ignorant, whereas the Scylla Manager is shard aware. That means it will take the entire token range of the cluster or the node that it needs to repair, and it will divide it to multiple small token ranges per the amount of shards. And it will run that sequentially and parallelly. So to utilize Scylla's great parallelism with its shard architecture. And node tool repair, finally, doesn't have retries, whereas the Scylla Manager, in case of a failure, it knows how to perform retries only on that specific small token range, the mini repair task that were created. And you can also customize the number of retries. So let's talk about the Scylla Manager monitoring dashboard. So as for the Prometheus integration, we have the active repair task, which can be 0 or 1. Only one task runs at a time. You will see the repair progress next to it. We have the repair rate, which means how many segments were completed in the relevant time frame. The segments are the small token ranges miniature tasks that I spoke about earlier. The repair error rate is how many segments failed in that relevant time frame. Alerts in case of repair that has failed. We have alert support here, and alerts in case of Scylla Manager exits. In Monitoring Stack 2.0, Manager dashboard includes the same cluster status report, and a new alert was defined in the Prometheus Alert Manager to report when a Scylla node health check failed, and the node is considered as down. Repairing failed segments. Should a segment fail for any reason, Scylla Manager will skip that segment until other segments have been repaired and completed successfully. It will then go back to the skipped segment and try to repair it a second time. Each repair attempt is considered as a retry. The number of retries is configurable in the Scylla Manager YAML. So as for availability, Scylla Manager starting from 1.3 can be installed not only on CentOS 7 as it was up until 1.3, it can now be installed also on Ubuntu 16 and Debian 8. And of course, it can manage Scylla clusters running on all the supported OS for Scylla. Now, let's talk about the Scylla Manager roadmap. Here is the roadmap, and like any plan, it's subject to changes, and your feedback is more than welcome. Our product manager will be happy to follow with you one-on-one. So, Scylla Manager 1.2 introduced the multi-DC support, the auto-config, the SMB and shards, repairing subsets of nodes, and Ubuntu Debian packages. Scylla Manager 1.3 introduced the CQL sampler, which is the health check that I mentioned earlier. Now, what's coming up next in Scylla Manager 1.x? In future versions, we're going to have recurrent backups. Initially only to S3 buckets, but later on, it can be to any destination or mounted drives. We're going to have improved repair for time windows, and we're going to have a secure backend connection. Later on, in Scylla Manager 2.x, we're going to have unified packaging, which means we're going to have the monitor and the manager together, which will save time deploying each one on a separate box or on the same box. It will be easier to deploy. We're going to have cluster setup, including the monitoring, cluster management as well. Scylla Manager will be able to perform out or downscale, rolling upgrades, rolling configuration updates, and it will also be able to perform log collection, which will be helpful for reporting tickets. Further on, in Scylla Manager 3.x, we're going to have cloud management, admin security, migration tools, etc. So the plan is to make Scylla Manager a fully enterprise management tool that will complement Scylla and will be a great tool for all of you to use. So now let's talk a little bit about our ticketing system, as Eyal mentioned. Let's talk about how we open a support ticket. Okay, so we are using Zendesk. And if you don't have access to your Zendesk account, or you don't know how to do that, please contact us. We are more than happy to show it again. So first of all, you register to our customer zone. This is the form that you will see. Then you will get this message that you need to confirm registration details and your password. This is how it's supposed to look. We also implemented in our systems a single sign-on, SSO. When logging to the customer zone, you can download Scylla and not register over and over again. You can also log in to Zendesk directly using the same credentials. So that's a nice enhancement. Third step is to go to scylla.com/support and click on Submit a Ticket button. You will be automatically redirected to the Scylla support portal where you can log in and submit a ticket. Now let's look at the ticket details. This is the form of opening a request or a ticket. We have the subject, which we recommend to fill in, of course, with informational detail, which will be very clear. We have the description, which is free text. We can put a lot of more information there. For instance, about your setup, how many nodes, the amount of data, and what actually happened. And we have the attachments, which are for uploading logs or screenshots or whatever. And if the attachment file that you want to add is too big, then we have the procedure of the information collection, which I mentioned at the beginning, where you can upload all our information to the GCP bucket. In that case, you can just paste in the ticket the UUID that you got for the bucket with all the information that you uploaded there. There you can upload very large files. And now let's talk about the priority marked in red here. It's very important. The default priority is urgent, but we have 4 priority levels for ticketing, okay? We have urgent, which is meant for production environment is down, the data is lost, or you have data corruption. The second priority is high, and that is meant for production environment is degraded, meaning you lost a node, but the system is still functioning. Production environment has major functional issues. You cannot, you have some driver issues, or there is some specific Scylla functionality that you cannot use, or for production environment suffers from major performance problem. The third priority is normal. That's for production environment suffer from minor performance issue, or the staging environment has some issues. And the last one is low. That's meant for questions enhancement requests, etc. We want you to be aware that the first priorities, the first two priorities, urgent and high, triggers on-call engineers to help resolve the issue, no matter the time or the day, okay? People will get phone calls and messages and emails to jump and start helping you. And I wanted to mention that our average response time that we measured in the last 11 months show that we provide a human response in Zendesk tickets within minutes, usually under 15 minutes. And that's a great response time. So before we say Happy New Year, here's a quick recap. Make sure your cluster has backups. Make sure you have enabled our security features and go over our security checklist. Make sure to monitor Scylla, preferably with our monitoring stack, but there are other options as well. Make sure you know how to interact with Scylla support. If you have an issue, you have a link here on how to collect and what's the exact information that we need. You have there also the procedure to upload big files or big attachments in case you want to open a Zendesk ticket. You can use the GCP bucket here as well. And last but not least, we encourage you to use the latest Scylla Enterprise version 2018.1.7 whenever that's possible, because there are critical security patches or data corruption patches that we want you to have, and you should always strive to be on the latest Scylla version. Thank you very much. That concludes the part of the Scylla Manager and the ticketing. And now back to you, Eyal.
Thank you, Tomer. That was great. We have a few minutes for your questions, so go ahead and type them into the Q&A section if you find it on the lower part of your console. I got already two questions here, so maybe we start with those. How do I get resiliency if the Scylla Manager node fails?
So, as I mentioned, the Scylla Manager by default will install a local Scylla or single node cluster as its backend, running on the same instance as the Scylla Manager. And that doesn't give you a lot of resiliency. But there is another option, which we also mentioned in the webinar here, that you can use any Scylla cluster as the backend data store for the Scylla Manager. It could be some Scylla cluster that you raise of 3 nodes or 5 nodes, and the Scylla Manager will save all its state there, and this is how you get the resiliency.
Thank you. The other one is, why do I need those 2 backend store, both Prometheus as well as the Scylla backend one?
So let's just jump back to the diagram, and I'll explain again. Okay, so the Scylla Manager has its backend as the backend data store. The Scylla cluster will be the backend data store for Scylla Manager. The Scylla Manager needs that because we designed Scylla Manager to be stateless. All the information and all its states is kept in the backend data store. And that means that if something happens to the Scylla Manager itself, you can always start a new one and you don't lose any information. All the information was in the backend data store. The reason you need a separate box for Prometheus, Grafana, etc., is to have the metrics from Scylla Manager on your monitoring stack, okay? The Scylla cluster is not a monitoring stack. It just saves the state of the Scylla Manager. But if you want to be able to monitor the Scylla Manager, to see the progress of the repair task, to get alerts on failed repair task or a failed node, or if the Scylla Manager exits for some error, on an error for some reason, then you need to have our monitoring stack. And the monitoring stack is always recommended to have its own separate instance. Okay, so not to compete on resources with the Scylla cluster. So that's why we have the backend data store and we have the monitoring stack as a separate box. By the way, the monitoring stack and Scylla Manager can coexist on the same node, okay, in terms of resources and the hardware requirements. So that's also an option.
Perfect. that concludes the Q&A. So again, we hope you enjoy the webinar. And if you find this webinar platform useful for you as a customer, we will continue to have these customer dedicated webinars throughout 2019. We thank you for your participation and hope to support you and give you more information throughout the next year. Happy New Year to everybody, and thank you for joining.
Thank you.